Hey guys, Mr. Milton here. Today we're going to look at ratios and proportions notes. At the end of this video, you should be able to understand the difference between a ratio and a proportion. You should be able to use the properties of proportions to rearrange proportions, and you should be able to set up and solve proportions. All right, so some vocabulary first. Another name for a ratio is a fraction. Okay. And a proportion is a statement of two ratios that are equal. Okay, so let's go into some properties of proportions. This first one should be pretty familiar, even though you might not have seen it framed in this way. But we know that if A over B equals C over D, then AD equals BC. Okay, and all that is cross multiplication, right? So if we have a fraction equal to another fraction, we can use cross multiplication. Wow. All right, so solve it. And we know that that's true. Okay. Also, it's true if A over B equals C over D, then we can say that B over A equals D over C. Okay, and this is the reciprocal property. Reciprocal. Okay. All right. Again, looking at this ratio, we can also say if A over B equals C over D, that A over C would equal B over D. Okay, and I'll just show this really quick. If we had, let's say, 1/2 equals 2 over 4, right? So A over C, B over D. Then if we did this and we said A over B, that would be 1 over 2 equals 2 over 4. Okay, we see that it stays the same. It might not keep the same numbers as it does here, but the ratio will be the same. This side will be equal to that side. And then finally, if we had A plus B over B, that should equal C plus D over D. And this looks a little bit confusing because it's like, wait, what a second, why? But as we look at this and we kind of separate it, we can rewrite these fractions to help us understand why this is true. A plus B over B, we can rewrite this as A over B plus B over B, right? And that should be the same thing. On this right side, we have C plus D over D. We could rewrite this as C over D plus D over D. You might say like, well, how has that helped us out? We still have all these letters. Well, anything divided by itself, as we have B over B and D over D, becomes 1. So really what we have is A plus B, or say A over B plus 1 equals C over D plus 1. Which, if A over B equals C over D, then yeah, if we add 1 to both sides, it works out. It should still be equal. Okay, so here are our 4 properties. We'll use these as we try to make sure that we're using correct similarities or ratios. Okay, and this will be important as we go through the chapter because our chapter is dealing with similarities. As long as we're using any of these ratios correctly, okay, you might have a little bit of different process on the way to our answer, but we should be able to get to the same answer as long as we're using these rules correctly. All right, so here goes. Let's finish the statement using the properties above. A over 4 equals 12 over B. So if A over 4 equals 12 over B, then AB looks like they're cross multiplying. Cross multiplying 12 times 4 would be 48. All right, so we got there doing 12 times 4. Number 2, B over 12 should equal, so it looks like they're using the reciprocal for the right side. We'll use the reciprocal for the left. 4 over A. And then number 3, A over 12 should equal 4 over B. Okay, as they put numerator over numerator, should be the same as denominator over denominator. All right, it says solve each of the proportions for your variable. So here, as we solve for proportions, we're really going to use cross multiplication here. And so we'll be solving for the value of y. I'm going to cross multiply these two. Okay, remember that when we're cross multiplying, we have an expression here. We want to make sure that we distribute to both terms. So I should have 4y plus 12 equals 8y. Okay, subtracting 4y from both sides, 12 equals 4y, divide by 4, y should equal 3. Okay, trying the same thing with this next problem. X times 2x equals 3 times 6. Okay, and so we can simplify this as we multiply this. This gives us 2x squared equals 18. We need to solve for x, so I'll divide by 2 on both sides. I get x squared equals 9. And then to find the value of x, I need to get rid of the square, so I'll take the square root of both sides. Okay, remember that square root of 9 could either be 3 or negative 3. Either of these answers works. Okay, so make sure that you use both of these as options, and then we can eliminate anything that would be nonsensical. Like if this were the length of a line, we'd then be able to eliminate negative 3 as a possibility. But since it's not, we're good. We keep both of these as answers. Okay, last problem. You'll see that we're multiplying binomials here, so that might be a little bit of a blast from the past there. But our process is the same. We're going to cross multiply. Okay, and so I'm going to multiply x plus 3 times x minus 2 and 2 times 7, which is 14. Okay, so I'll have to FOIL. X times x is x squared. X times minus 2 is negative 2x. 3 times x is 3x. 3 times negative 2, negative 6. Okay. Combine my like terms here. I get x squared plus x minus 6 equals 14. And so you'll see we get here, we have an x squared and an x. And in order to solve this quadratic, we really wanted to set it equal to 0. So I'm going to subtract 14 from both sides. I get x squared plus x minus 20 equals 0. Okay, so we have to solve this quadratic. Now, the way that we solved this quadratic last year and learned to solve it is factoring. Okay, you could use this as a quadratic formula, but when a is 1, we typically want to factor. And the little game that I came up with is that you want to find two numbers that multiply to give you a times c, and at the same time add to give you b. Okay, so just looking at the general form of quadratic, a in this case is 1, c is negative 20, so we want to find two numbers that add to give us negative 20, or sorry, multiply to give us negative 20, and add to give us 1. Okay, so I can think of those numbers pretty quick, and that's 5 and negative 4. 5 times negative 4 gives me negative 20. 5 minus 4, 5 plus negative 4 gives me 1. So these are our two numbers that work. And so I can factor this quadratic into x plus 5, x minus 4 equals 0. So now this left side is changed into these two factors. From there, we use the zero product property. Remember, that means that if I multiply two numbers and the answer is 0, at least one of these two numbers has to be 0. So then I solve to see what values would make that true. So either x plus 5 is 0 or x minus 4 is 0. Subtracting 5 from both sides, we get x equals negative 5. Adding 4 to both sides, we get x is positive 4. So the two possibilities here, negative 5, positive 4. Okay. And our final question here says, set up and solve the proportion for the given word problem. On a certain map, the scale is 3 inches equals 70 miles. If the distance from Fort Wayne to Indianapolis is 110 miles, how far is it on the map to the nearest tenth? So here's our proportion. We have 3 inches to 70 miles. So we want to set up a proportion on this side, And our labels are really important because when we set up our labels, it makes it a lot easier for us to know where numbers go. Okay. What we know in the second part is that our distance, our actual distance is 110 miles. Okay. And so as we see our actual distance here in the left side in our ratio, it's 3 inches map distance to 70 miles actual distance. We're given the actual distance of 110 miles, so I want to make sure that I put that in the denominator. Okay, I don't know the map distance. That's what they're asking me about. So I'll make that a variable. Okay, but my labels help me out so that it's not confusing on where these things go. Okay, and so now I can solve for x, and I'll do that by cross multiplying. 3 times 110 gives me 330. X times 70 gives me 70x. Divide both by 70. And so x should be 47 point, let me do that on a calculator. 330 divided by 7, 47.14. Okay, and then the directions tell us to the nearest tenth. So on our map, it should be 47.1 inches away. Did I do that right? No, I divided it by 7 instead of 70. Okay, I thought that was really big. Let me do that again, but correctly this time. There we go, 4.7. That makes way more sense. I was about to say 47 inches on the map. That's a 4-foot map. And that's why we want to make sure our answers make sense. 4.7 inches. That's how far away it is on the map. Make that right as well. All right, so there we go. That's using or setting up ratios, using their properties, and solving them. See ya.